running about 10 watts and an omnidirectional antenna. So it's not a very strong signal, and it is varying. But what I was interested to do was compare the performance of two antennas. Now, the two antennas that you see in the picture, the 18 element, the smaller one there, is the one that we did as a club exercise a couple of years ago, and about 15 people built them.
Yep.
They're built on a fiberglass, standard fiberglass 1.2 metre fence post, and only a nice small antenna that people generally use for our Sunday morning 1296 meg QSO parties. We all point at Mount Wellington, and this little antenna has enough gain to bounce off Mount Wellington to elsewhere in Hobart.
It does very well.
Yeah. The longer antenna is the one that I'm actually using, which is built on the same principles, just with a longer piece of fence post. It's almost 3 meters long. It's got 37 elements, and it's both these yagis were built to the VK5DJ yagi calculator, which is on the web and is based on the DL6DU yagi design. DL6 designed these yagis, must be getting around 30 years ago, before computerized, and he did it all manually and so forth, but they stood the test of time. Modern computerized yagis can generally get another half a dB, but they become very critical, and the advantage of the DL6 is if you make a small mistake, they still work just as well.
Cool.
Where some of the optimized designs, they pick up the half a dB and then you get a raindrop on them
and they're
no
longer performing.
That's right. So I love these DL6 designs, and I was interested in comparing the performance of these two yagis. Now, according to the VK5DJ spreadsheet, there should be 3 dB difference between the two. We go to the next slide. So what I did is I set up so I could switch between one yagi and the other, and I had an identical preamp on both of them, so it should measure the difference between the two yagis. Now, if you can see this graph, you'll see it's varying, and that's just propagation, which you don't have too many choices about.
Yep.
But you can see a pattern where it's switching from one yagi to the other. Every time there's a red bar, it's on the longer yagi, and it's generally higher. And when between the red bars, it's lower on the smaller yagi. Now, there are occasions when, because the propagation's changed, there's only 0.7 dB difference.
Okay.
But there are other occasions where there was 5.3 dB difference. So to measure the difference, you've got to average it over a number of periods, and so I set up a little timer to switch a coax relay between the two, and then average the results, and the average difference came out at 2.95 dB compared to the 3 dB that is calculated.
Theoretical. Well, there you go.
The next test I did was I took the preamp off the small yagi, and it then had about 6 meters of coax as well before it got to my 9700. So that added another 1.1 dB of loss, and I compared the two under these conditions. So effectively I'm now looking at the noise figure is established by the loss in the cable plus the radio compared to the low noise preamp. The cable's costing 1.1 dB, but the average difference has now gone from 3 dB to 4.7 or 2.975. So if you take account of the cable loss, I've only lost 0.6 of a dB as a result of not using the preamp on the very low noise preamp and using the 9700. So I regard that as very good performance
From the 9700.
from the 9700, which it's sure it's got a preamp and the preamp was in place, but to be getting within 0.6 dB of a DB6NT low noise preamp
It's pretty reasonable.
is pretty good. So happy with that.
Okay.
And I think that's all we've got to say, other than to conclude that the antenna gain is pretty well spot on, and the additional loss of operating with out of preamp and with 6 meters of cable is only 1.75 dB. I should say though, 6 meters is not a long amount of cable, depending on
What sort of cable was it, Rick?
LMR 400,
Okay.
or it's called LMR 400 dB. Now the dB doesnn't stand for decibels, it actually stands, and I don't know why they say use dB, but it actually means it's more flexible than the standard.
Oh, okay. So it's got a multi-chord centre conductor? Or is it
multi-stranded, yes.
Okay.
The difference is not dramatic, but for ham use the flexibility's worth having.
Yeah. It's a bit of a pain because you need a different sort of connector though. That's another story.
I have found that the best thing is to buy the cables with the connectors put on. We probably shouldn't advertise who it is, but the
RF shop.
No, it's not.
Oh, okay. Okay.
There is a company in New South Wales
Okay.
who will sell you LMR 400 at the real price, even if you only buy 6 meters.
Okay.
And they will put the connectors on, and the price is not bad. To have a connector put on, and they provide the connector, it's about $12 for each one.
Yeah.
And they not only at the end of that, they send you a graph showing you the loss.
Oh, so they actually test the cable.
Test the cable, and they show you the loss. So
Fantastic.
it's a good way of
That's
getting
a good investment, actually.
and that they turn it around in about a week. I mean, you got to pay delivery from Sydney and so forth, but you get the cable the length you want with the connectors put on, properly sealed.
Yep.
And you know, faulty connectors are often
The cause of much pain and heartache.
Yeah.
Anyway.
So, looking at if you use that same cable and instead of had 6 meters, you had 20 meters, that brings you up to about 3.5 dB loss.
Yep.
And at 1296, that's the equivalent of not having a big long yagi.
Correct.
So you have to think about coax loss at 1296. It's actually a little bit worse than that, because not only does the cable attenuate the signal, it actually generates noise. On terrestrial, that's not a big issue, because usually your noise is established by,
What you're pointing at.
well, 1296, it's never very high. I mean, you're gonna, if you're beaming right at the horizon, half of it's ground, and the ground's about 300k.
Yep.
So you're always going to have about 150k, but you will in a city area, because people have LED lights and things. You have a couple of dB more. So the actual cable loss is not a big factor, but it is going to cost you both attenuation and noise.
Okay.
So that's the first talk.
That's a good, good comparison, Rex. Very good. And so, what's our next talk?
Okay. Some of you have heard about the IC9700.
And if you haven't, you've been living under a rock.
I mean, this is a really wonderful radio. I love it, and it's I reckon for the price it's really good value for money. It has one problem for people who are interested in really weak signal digital modes, which is stability. And
Okay.
the essential problem, if we look at the next slide, is it says here 10 megs reference signal input.
Hang on, let's go to it. There we go, there's the rear panel.
Yes, and the bit with the black
Line around it.
It says 10 megs reference input. Most of you would think, and that arrow points to a little SMA socket, which looks perfect. And because most other radios that ICOM make that have 10 megs reference input, properly GPS allow you to use a GPS locked source at 10 megs, you might assume that this one does. Unfortunately, for reasons that are not apparent to anybody else,
That are unknown to us at the time.
what this reference input is, you put a reference signal in there and you can then press some buttons that go down a few levels and it will calibrate the radio to it, which sounds pretty good, except then it continues to drift and the oscillator in it is not very good at all.
Okay.
In my view, it is not as good, it's certainly not nearly as good as the high stability oscillator that was available for the IC910,
10. Yeah.
and it's probably even worse than the standard oscillator in the 910, and the reason it's worse is the fan causes the oscillator to drift. The air blows right over the board on which the oscillator is,
Okay.
whereas the 910, the oscillator was out on its own and wasn't subject to the fan effects.
Okay.
So
And does that, and the fan comes on and off, I assume, based on transmission and.
it's not absolutely clear what it comes on and off from.
Okay.
It's certainly, if you transmit digital, it will come on and off when you transmit, because it's a full envelope mode.
Yep.
If you transmit SSB, sometimes it doesn't come on,
Right. Okay.
and you'll get away with it.
Yep.
You know, you don't have it. If you, I thought that at 1296, because the radio only gives 10 watts out at 1296.
Okay.
It gives 100 watts out at 2 meters, 75 at 432.
Moon's up.
Right. I thought it was probably stable at 1296 because the fan never came on when I transmitted.
Okay.
However, the fan also comes on if the temperature rises, the ambient temperature rises, and we'll look at this in the next slide.
Okay.
This shows the drift at 1296, and this sort of curve shows about 400 hertz drift in about a 15 degree temperature change.
Okay.
But here you'll see it's going on and off rapidly, and that's caused by the fact that the fan is coming on and off and cooling the board.
Yeah. Yep.
And that's causing about 300 hertz jumps in a very, I mean that's about 16 hours, that's sort of,
Yeah.
but these jumps are only about 4 minutes. So this is a very rapid jump, and clearly that means if that jump occurs, digital just doesn't work.
Yep.
In fact, even sidebands a problem if you've got a 300 hertz jump over 4 minutes.
Correct. You go from duck talk to extreme duck talk.
Now, if you're prepared to keep tuning, you can get away with it on sideband. If you come back, we'll now go back to 2 meters. Here is the jump amplified up, and it's only a ninth of what it is at 1296 because that's the frequency relationship.
Yep.
So it's about 30 hertz. Even 30 hertz at 2 meters, you to resolve a sideband signal, you start having to tune if the fan comes on.
Yep.
Now, if the fan doesn't come on, then this is not an issue.
Yeah. Okay.
Now, the fan comes on certainly if the temperature goes above about 30, somewhere between 30 and 30 degrees C.
Yeah. Okay.
Now, that doesn't happen often in an air-conditioned house, but happens often if you're out in the field in Australia.
Well and truly.
But the fan comes on, I think, for other well, it certainly comes on when it thinks you're transmitting at high power.
Okay.
If you're transmitting sideband at high power, it sort of makes a different judgment, and sometimes it will come on and sometimes it won't.
Right.
So whether you get these jumps really depends on the way you operate the rig.
Okay.
And for example, if you use this on whisper, well, 30 hertz will kill whisper.
Well and truly. And
But-
it's 2 minutes. It's
And
2
it's
minute
two-
cycles.
That's right. So what actually happens on whisper is if you transmit, say, at a 50% duty cycle, nobody runs whisper at 50%, but if you do, the fan will stay on in a regular fashion, and the drift will be much less, and it will work.
So if the fan stays on, it's not so bad.
It's really good. In fact, I have rewired mine
So
to
the
put
fans-
so the fan is permanently on,
Okay.
and that's sufficient to make this radio quite viable for all digital modes,
Okay.
including whisper on 432.
Okay.
In fact, including whisper on 1296, although there's some other issues to do with propagation that we've found
Okay.
come into play there. But for short distance on 1296, it's fine.
Okay.
So one option is to put the fan on. The difficulty with that is that solves the short-term stability,
Yep.
but you still get the long-term temperature change. And in fact, it makes it, the fact that the fan is on,
VK7MO on the domain tonight is listening.
Oh. Okay.
the fact that the fan is on, it actually forces any temperature change into the radio more rapidly.
Right.
So if you're out in the field and the sun
So the
shines on,
fan's sucking air in.
yes, no, it's sucking it out.
Okay.
Uh,
So it's drawing it in from somewhere else in the case.
Yeah,
Yeah.
and
okay.
and so if you weren't drawing air in, the thermal mass of the radio would keep it more stable to external temperature changes.
Yeah. Okay.
So you sort of solve one problem, but you make the radio more sensitive.
In others.
So
Okay.
the real answer is we need this radio to be GPS locked, like we all expected when we saw
A 10 meg reference input.
when we saw a 10 meg reference input. Now,
Okay.
I have a friend in Canberra, Glenn English, who actually designs SDR radios for a living, and he agreed to have a go at GPS locking this radio for me.
Glenn.
Yeah. Now, this picture here, it's, I don't know whether people can see, but there's a board being added here which is stuck on with capped on tape, and then a lead going off to the 10 megs reference with capped on tape, and so this is a prototype.
Yeah. Yeah.
But it works extraordinarily well. So instead of having 300 hertz drift at 1296, if we look at the next graph, here is the drift at 1296, and this is only plus or minus 0.2 of a hertz.
Oh. Okay.
So we've improved the performance by about 0.2 of by about 1,000.
Yeah. 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 Yeah.
What is also interesting is this is when I was using a separate GPS to drive my signal source and my radio.
Okay.
If I use the same GPS, it was perfectly stable. So there is just no drift whatsoever in the radio.
Fantastic.
The drift is totally a function of how much money you spend on your GPS. And in those terms, this is, some of you will be aware of the postage stamp GPS. Now,
Yeah, I am.
the postage stamp GPS is about $150. It's got a TCXO in it, but it doesn't have an oven. However, what I do is I put them in a die-cast box to buffer any thermal
Yep.
changes, and this is the sort of drift that we're getting, which is about plus or minus 1 hertz. Here's the drift with my double oven GPS, and here's the drift when both radio and the they're both locked, as per the previous slide. This is an amplitude variation that causes that blob in the middle, but essentially you go from about 1 hertz to about plus or minus or down to about 0.2 hertz, down to nothing.
Nothing. And we're looking at, the bottom is the postage stamp, the middle is a Fury, so that's
Yeah.
a different sort of GPS disciplined oscillator.
But it's double oven.
Double oven, and then we go to a Firefly 2
Well, that's a Firefly on both.
on both. Okay.
On both. So
Okay.
this was a Firefly on the signal source and a Fury on the radio,
Okay.
and a postage stamp on the radio.
Yeah. Okay. So that's Firefly on both.
Yes, and Firefly on both, essentially no drift out of the radio, because they're both drifting together.
Okay.
Okay, now, having got my radio GPS locked, and I should say, well, I think this is a terrific solution. At this stage, we don't think that this is going to be something that hams generally can do.
Okay.
The size of the components in this radio is a couple of orders of magnitude less than the 9100, which we worked on here.
Yeah.
And that was
last week.
pretty hard.
That's second or third generation surface mount. So,
Yeah.
Yeah.
So to do this radio, you need both skill and the right equipment,
Yeah.
which Glenn has.
Yeah.
And it would be pretty dangerous having hams generally attempting this on a new radio that's got a 5-year warranty.
Well and truly.
So we're still hopeful that ICOM will find a solution,
Yep.
rather than have to provide boards.
So the key message tonight is don't do this at home.
No. and keep the pressure on ICOM to
Yeah.
find a solution.
Unless you want to avoid your 5-year warranty.
Yes.
Okay.
Okay. Now, this is what it looks like operating. What I have done here, I've set up a WSJT in echo mode, and on this occasion the echoes were about 30 hertz wide.
This is Echoes Off the Moon.
Echoes off the moon.
Yep.
And you can see it's perfectly stable, and you get a brilliant, by the time you integrate that over, I think, about 20 echoes,
Wow.
you get a brilliant echo response. So very happy with the GPS locked radio. And
How is it? Just a left field question here, Rex. How easy is it to use the 9700?
I think in most cases it's really very easy to use.
Okay.
But there are a few things that sort of catch you out until you read the manual.
Okay.
And they're not quite intuitive. Like the first thing that caught me out is just changing bands. Now you'd expect when you change bands that there'd be a very simple button that said 144, 432, 1296, and you just flick between the two. the way you have to change bands is you press the frequency that's on the touch screen,
Yes.
and if it's say 1296, you press 1296. It brings up another screen and gives you the option of selecting 432, the last frequency that you used on any of those bands.
Okay.
Well, the last three frequencies that you've used on any
Right.
of those bands.
Okay.
And I've sort of learned to live with that, but I guess I thought you wouldn't have to go through double steps
Yeah.
to change bands. As well as that, for a lot of frequencies that I use, I have them in memory, and like the beacon down here and the beacon up here,
But Don,
and so you've not only there's a separate set of memories for each band, so you can't just, you've got to get onto the right band before you can select
the memory that you've got.
So you finish up with about 4 steps to get to where you want to go.
Yep.
It's not a disaster, but it just doesn't. I mean, I'm probably a bit old-fashioned where if you wanted to change bands, you pressed a button and you changed bands.
There's a band switch. Yes. Okay.
But I understand in this modern world, there's not enough real estate for buttons.
Correct. And just taking up that point, is there any? I know a lot of these radios, you have a whole range of menu items that can be multi-layered.
Yes.
So you go to that menu item, but it's not just a sort of a binary on-off. It can be that leads you into the next menu item, which then leads you into the next menu item. Which is there a sense that's in there? They're multi-layered.
It's certainly multi-layer. I would say 4 or 5 layers quite often to get to what you want.
Okay.
And if you don't use the function very often,
you're back to the manual.
Unfortunately, hams of my era don't read manuals. They tend to just keep pressing buttons to try and get to where they want, because that's what we always used to do, and that doesn't work. So I've started making a list of all the common things I want to do, which I put by the radio. So
I wouldn't worry, Rex, because I've got a shortcut list that that's laminated that goes in my soda pack for the 817. So.
Okay, well, I think it's a feature of modern radios.
Correct.
The list is required because there's not enough real estate.
Yes. Okay. Cool.
All right. So having got nice echoes, there was a de-expedition that went out to Crete.
Oh, okay.
And this is the first time Crete has ever been activated on 10 gigs.
Okay.
Now the problem was, where they were set up, they were pointing through these damn trees.
Yeah, not an ideal location, but anyway.
Now this was fine because most of the path, this was moonrise.
Okay.
Unfortunately, moonrise is, for them, is moonset for us.
Yep.
And we didn't have much common window because where I am, I've got a house next door which I've got to get over.
Yep.
So they had to try and work me while the moon just sort of crept between these trees. Because of the aperture of their dish, some of the dish was seeing
very noisy trees.
Noisy trees. So now this dish, it's a 1.5 metre dish, so it's bigger than my 1.13 metre dish, but he's only getting about 9 dB sun noise, whereas I'm getting about 9.8 dB.
Yeah.
And for a smaller dish, and I think the explanation is this is a mesh dish, and at 10 gigs some noise is getting through from the back.
Okay.
It's also made up of all these petals which have to be assembled, and it's hard to assemble a petal dish exactly right
aligned
on 10 gigs. So I would say his dish was probably effectively was smaller than my 1.13, even though it's a 1.5.
Yep.
Now he does it on all bands from 1296 up. So on the lower bands, this dish should be fine. Although it's not a really big dish for 1296, but it's a compromise.
Okay.
So notwithstanding that, if we go to the next slide, I had a relatively quick QSO with him. He called CQ SV9HB9CRQ, which is his home call, and the SV9 is for Crete.
Yep.
And I went back and we finished the QSO with all zeros.
Wow.
So no prior knowledge was required. The frequency was a bit off, 982. By the end he got up to 1002, so he was only 2 hertz off, so there was a little bit of drift.
Okay.
I was sort of worried where that drift was, because I thought I was perfectly GPS locked.
Yep.
His IF radio was not GPS locked, so
This was the 9700 for you?
for 9700 for me.
Okay, cool.
So I was very happy with that result.
Yep.
Signal levels sort of minus 21, 21, 20, 20, 21, 20. You can see after he worked me, he went on and worked a JA.
Cool.
That was. I mean, I'm not saying that the 9700 is any better than my 910s, because they're both GPS locked,
Yeah.
and the
Yep.
noise figures established by the transverter.
Yep.
But it's much simpler radio, because all of the audio and PTT and cat control is done over a single USB cable.
Yes.
So it removes a lot of extra bits and pieces.
Yep.
So it'll be a good radio for portable.
Cool.
And now it's GPS locked. It is at least as good as my
9100.
Yeah.
No, 910.
910.
Sorry.
It does have an advantage over the 910 in its pass band. The SD radio has a beautiful flat pass band.
Yep.
The 910 has ripple of about anything up to 2.5 dB.
What? How much of the passband can you actually get access to?
It's certainly flat from about 200 hertz to about 3 kilohertz.
Yeah. Okay. Okay. So standard passband.
You can adjust it up to 3.6 kilohertz, but when you do that, it actually causes a hump at the bottom.
Right.
So you've got to live with that sort of top frequency of 3 kilohertz. I would have liked that to be higher up, but that's okay.
Okay.
I mean, normally if both stations are GPS locked, they're exactly on 1000 hertz at one end.
Yep.
And if you're using QRA E, that's 1.8 kilohertz higher.
Yep.
So you're still within the flat pass
The
band.
band. Yeah. Okay.
But if you're working stations who perhaps are not accurate in frequency, it'd be nice to have more than 200 hertz in reserve.
Yep.
And for some situations, it'd be nice if we had radios that went, say, to 5 kilohertz. We could talk Joe Taylor into going beyond QRA E to F and G, and
More tones. More.
more widely tasted tones to cope with spreading.
I'm just surprised that you can't actually do that with the radio, because my understanding is, and I haven't read this up, but it is a digital up and down conversion radio, and so the passband should be able to be set to almost anything.
I suspect it's possible, but not with the way they've set it up.
No, with it, yeah. They've gone with a standard.
There are basically 3 filters on every mode.
Yep.
And you can have a wide, medium, and narrow
Yeah.
filter.
Okay. Can you have a variable filter? Is there a variable in there?
Only
that you can set?
only around those individual ones.
Okay.
And not a lot of range. Certainly 3.6 is as wide as possible.
Okay.
In the default value, it's 3 kilohertz.
Yeah. Okay.
And you can push it to 3.6.
Yeah.
But then you sort of muck up the bottom
The
end.
bottom end. Yeah. Okay.
Probably not an issue because the bottom end, we don't often use below 1,000 hertz anyway.
Yeah. Okay.
But when you see the lump at the bottom, you think,
Yeah. You don't want to go anywhere near that.
So I stick to 1,000 hertz.
Cool.
But so my conclusions are that the VK1XX GPS locking reduces the drift at 1296 from about 400 hertz to about 400 millihertz. So
That's pretty good.
that's 1,000 times improvement. The drift's entirely dependent on the quality of the GPS DOs. So if you had better GPS DOs, you could even do better. But I'd have to say we are all, even at 400 millihertz, most of the modes have tone spacings. Well, QRA's 1.75 hertz tone spacing, even if you went to QRA A.
Yep.
Whisper's 1.45.
Yep.
So even 400 millihertz is well within the tone spacing of any mode we've got at the moment.
Yep.
So
Okay.
not an issue. There is the problem of whether hams would be able to do this mod even if a little board was made available to them. So hopefully ICOM can come up with a similar modification that doesn't void the warranty.
Well, it could be an opportunity for them because they could say we can make your radio ultra stable.
Yeah.
for just send your radio back and we'll we'll do this modification. So
Yes,
Yeah.
I think it'll have to be a factory mod.
okay.
Yeah, I mean, hopefully just in Australia, where they've got some people who can solve it very carefully.
Correct.
So, thank you.
Thank you, Rex. That's excellent and good to know that there is a solution for your 9700.
Yeah, I mean, I should say, if anybody wants a radio for general use, sideband on 2 meters, they won't have any problem with the radio as it stands.
Yep. Okay.
If they want to go to sideband at 1296, they'll be tuning around a bit and they probably live with it.
Yep.
But if you want to use it on FM, it's a beautiful radio.
Yeah. But if you're wanting it for weak signal modes,
Yes.
then you're going to have to consider a solution of some sort.
Yeah.
So-
I mean, you'll get it to work, but you won't be getting the full benefit of the
Yep.
mode that you're using.
Yeah. And by the sound of it, the easiest mod is to run the fan all the time.
That's right. Yeah.
Which is within the realms of I suspect most amateurs.
Yes. In fact, there's a little plug on the.
Oh, okay.
On
So
the-
you can just unplug it and plug it in.
In fact, that's the way I've tested it. I've just unplugged it and put it onto a separate power supply to run the fan full time.
Cool.
Yeah.
Cool. All right.
Okay.
Well, that's fantastic, Rex. And now you are. In fact, this is an excellent segue into the. Just let me do something here that I can bring up on the screen. Now, just let me go over here. Yeah, that's what I thought. Let me bring that back. We'll go over here. What I thought I would bring up here, if you just bear with me, and welcome Warren to the studio.
Yeah, good evening. Great to see the studio in action.
It's very good.
We meet again.
Now, what I thought I'd do here is, if we there we go. Now, what I've got on the screen, and I apologise for the we do have to do some improvements here, but what I've got on the screen here is the current list of Gippstech talks.
Yeah.
And there's some great talks on here. We are going live. Yes, we are. There we go. In fact, it looks a lot better on there than it looks over here. We've got Mark Spooner, who everyone knows, non-ionising RF radiation safety. Peter Schroeder, VK4EA, on VK4 RBB is now mixing it up. So that should be an interesting talk. We've got VK3 EIP, a portable 23 centimetre EME system for STEM applications. Dale Hughes, an automatic satellite ground station. We've got VK4 AMG, which is the Arduino as controller. You've got yours truly, which is the ZLPLL for the white box, and the K3NG, which we're about to have a look at up close and personal. We've got Hayden, VK7HH, repeater voting and simulcasting using the VK Link application. Peter Picorni, VK2 EMR on the leap second and status of UTC. And I sent him my leap second videos the other day, and he was very interested in them, so we might even get a leap second video in that. We've got Rex, VK7MO, with extending the 10 gigahertz EME world record. Dave Smith, VK3HZ, on the accurate azimuth indicator,
Which we'll be looking at shortly.
There you go, which is buzzing away out there. We've got Roger Harrison, Are We There Yet? So I'm not quite sure what that's about, but I'm sure it'll be entertaining. We've got VK5 APN on grid squares, VK4 AMG on the GPS discipline frequency reference, which is the one that Richard and I put into the IC9100 last week. And I think that's it at this stage. Yeah. Anyway,
I think we will have a talk from Glenn English on GPS locking into the IC9700 too.
Love it. So let's just move that back over here. Okay, and move back over here. All right. So we've got we've actually got some pretty reasonable talks in here. Some talks I'm looking forward to and hearing. And it's still it is. I think it's still open to, if there is a talk that you've got, contact Peter, and it's vk3bez.org is the Eastern Gate amateur radio club that runs Gippstech. Just make sure I got that right.
So these are the talks coming up?
These are the talks coming up and it's the 13th and 14th of July, so still a little while away, should be a good night, and it should be a good weekend, and we've got, I think, a record number of VK7s going.
I would think so.
Because we've got 4, 5, 6, at least 6 that I know of that are going from VK7. So it's looking pretty good, and it's Hayden's first time.
Yeah.
So and it'll be Richard's and Murray's first time too.
Yes.
So there you go. So we've got to treat them nicely. Yeah.
Yeah.
Anyway, so that's what's coming up. The other thing that I was going to do here was I don't know whether I've already got it up. No, I haven't. WIA was this weekend coming up, the 24th, the Friday through to the 26th on the Sunday, is the WIA Annual Conference, and let's whiz over here and do this. Okay, now the annual conference on the 24th, on the Friday, is of course registration in the afternoon, but the evening of the 24th is actually the Waverley Amateur Radio Society's centenary. Oh, Rex is calling. So the don't worry, Rex, we're not there. On the 24th, on the evening, it actually is being held at the Sydney Town Hall. The Sydney Town Hall, Waverley found out that there is a room in the Sydney Town Hall called the Marconi Function Room.
Oh.
Which is named after Marconi. It is actually
Right.
named after Marconi because apparently Marconi did something in the Sydney Town Hall at some point. And so that's where the Waverley Centenary presentation and drinks and eats is being held. And we have a talk by a guy called David Dufty, who wrote a book about ciphers and encryption during World War II and Australia's involvement in the secret wireless war. So and the Pacific War specifically. So that should be an interesting talk. And then
Is this coming weekend?
this is this Friday.
Well, you've got a bit on your plate.
So yeah, so that's happening on the Friday. I'm a bystander and observer on Friday. Thank goodness. But on the Saturday, then we head in the morning is obviously the AGM and then the open forum. We have lunch and then we've got a whole bunch of presentations in the afternoon. There are 8 presentations in 2 streams. We split them into 2 streams. So the first stream is sort of a bit of a policy, more information sort of stream, which is past, present and future education in the WIA, scientific CubeSat missions, the amateur involvement, what constitutes the amateur service, and RF in confined spaces, frequency management at large events. So they're the 4 in the first stream. In the second stream, which is more of the experimentation, is David Rowe, which is on FreeDV 700D and 2020, which is a new mode that he's come out with. Summits on the Air by Andrew Davis. The Epic VK Microwave Tour with David Minchin. So that was their tour of duty around the eastern board states with their 47 and 122 gig equipment. And then there's the Secrets of Kiwi SDR with Jamie Campbell. So that's the afternoon, and then we retire for some pre-dinner drinks, and then we go into obviously the WIA annual dinner that night. And the keynote speaker for the annual dinner is Professor Fred Watson from the Anglo-Australian Observatory.
Woohoo.
So that's going to be an excellent talk.
Where's the dinner taking place?
It actually is at the Park Royal, with the same place that we're having the AGM, Park Royal at Darling Harbour. So right in town. Then on the Sunday, we all get in a big bus and head up to Dural, to the AR New South Wales facility up at Dural. And there's Mini Trash and Treasure. There's a couple of talks going on with all-star linking and digital mode hotspots. There are a whole lot of static displays. There's some commercial providers up there as well. And yeah, you get to look around Dural, which is apparently a pretty impressive facility. So that's this weekend. And after about 11 o'clock on the Saturday morning, I'm no longer the president of or on the board of the WIA. So
Relief.
so yeah. So yes, that's I closed the book on that 2 years, and I will be doing quite a bit of other things with them. Anyway, so that's a little bit of. Let's go back to here. That's a little bit of our bits and pieces on. Now, okay. the next thing I was going to do, we'll go to the, we'll actually go to the close-up cam. Okay. Now last week I showed the spot welder transformer that I picked up at my favourite shop, the Resource Tip Shop, what I've done over the last few days is I've taken that all apart to have a look at it and make sure that it's actually it is put together half reasonable, because in finding the uninsulated fuse and a few other things, I was sort of a little bit dubious about the rest of it. But it looks okay. There is a lamination missing in the transformer, which might cause a bit of a buzz because the actual laminations are a little bit loose. But I'll deal with that. I can probably find a suitable piece of transformer material and fill that gap. But then I started thinking about how do I switch the high current, because a lot of spot welders, commercial spot welders, have a spring release button on it, where you push it and it only allows you to push the button for a certain period of time. It doesn't allow you to keep the button down, so that you don't put excess current through the metal that you're trying to weld together. So anyway, in thinking about that, I thought, what do I do here? And I looked in the scrap box to find some bits of scrap aluminium, and yes, it is aluminium that oxidizes. Yes, I know that. Before anybody says. So all I did was I got some insulating material. I turned up some spacers on the lathe, turned up a little knob, and threaded a bit of square rod, which enables make sure that the switch doesn't actually turn any further than I need it to. Put a spring in here with a nut on the end, and so we're looking at a high current switch. There's a hole in the panel that this goes through, which centralizes this button so that it doesn't move or do anything. So we'll trial this to see whether it is a reasonable switch for a couple of 100 amps to do some spot welding with. The thing that was probably the worst outcome is I push this down and it proceeds to weld itself closed. But anyway, there is a plan B to this. If that doesn't work, I was actually thinking I will relay control the primary of the transformer for a certain period of time. So, because of course there's a lot less current, and you could do that with just like a 10 amp relay, and that would be quite safe and not an issue. So that's plan B. If this doesn't work, I'll work on the electronic control of it, and just have and the thing about the electronic control is you can actually then have a bit more control in. You could put a potentiometer on the timer and have it for whatever you want to dial up as the time that it stays closed.
Yeah, so what, I guess in your research, what have you found to operate the spot welder? What sort of duration of current?
Very short. It is literally
seconds.
No, it would be at most like half a second.
Yeah,
and that's it.
Yeah, so up
And
to
how much
500
current?
milliseconds.
Oh, you're talking a couple of 100 amps.
You can actually do that with those big FF2s, couldn't you? The ones that like we used on the LEDs.
Yeah, on the big FETs. Yeah. You could, well and truly. If you wanted to switch the secondary, I'm thinking, well, it's much easier just to switch the primary with a timer and a relay.
Yeah.
I would think that might be easier too, and I would actually consider using a solid state relay there.
Yeah.
Having the advantage that they switch on while the voltage goes through zero.
Yep.
And switches off while the current goes through zero.
Yeah.
And then you could very easily just RC combination set the time that way.
Yeah. So anyway, that's plan B if this doesn't work. So yeah, that's the spot welder project. The next project, which what I'll do, we'll just go back to here and I'll zoom around. I'm just going to go past. Let me switch that off. Now, what you're stay there. What you're looking at here is, I mentioned last week that I had in the club rooms the. Actually, let me turn that around. I had in the club rooms the azimuth and elevation mount portable mount that I'm working on. This is what you're looking at here is a highly modified CCTV camera heavy duty mount. I've changed the motors from the AC motors that are there to DC motors with 1:40 ratio gearboxes on them for both the azimuth and the elevation. What I've also put on here is, and I'm not sure you can see that. Let's see. There we go. So what you're looking at there is an Omron incremental encoder, optical encoder inside that gives you 2,000 pulses per 360 degrees. So it's giving you well and truly sub a degree, and sub a 0.1, it's 0.16 of a degree if you do the calculations, I think, something like that. 0.16 of a degree, I think. And so what you're looking at there is that's been mounted so that the shaft actually goes into a little coupling arrangement. So as it turns like this, the whole assembly is turning, but the base is staying still. So the optical encoder is travelling around for up to the 360 degrees if it needs to be, actually needs to. And there's one of them on the that's the azimuth one, and then there's one on the elevation. If we head up, right there, see the elevation control. So and the really nice thing about those encoders are they're actually inside the assembly, so that when you are carrying it, there's not things sticking out all over the place that can be knocked and the calibration go out on it. So anyway, that's the mount, and it's all controlled by the K3NG controller. Now this is going to be interesting. The K3NG controller. Which is this box here. And you can see it's currently GPS locked, the little GPS symbol up the top. The optical encoder, those encoders are telling me where it is. If I move them, it's going up, and you'll see that's changed. Yep. And the elevation, same thing. The azimuth. Oh, sorry, that was the elevation, and this is the azimuth, and that's moved. It's got the time and date from the GPS down the bottom, and if I push the moon button, it will attempt to move to the moon, which is at 113 and 7 degrees. And I think that given that I hadn't calibrated that, will probably try and drive itself into the side because at 7 degrees, yeah, because azimuth elevation's at 354. So what we need to do here is bring that back to something like about 7 degrees. Work now. There we go. Yeah. So the only thing, it's brought that to the 7 degrees, the elevation, and it's moving the azimuth to the 112 that it needs to. And depending on where was it? It's at an azimuth of 4.3. So it's probably moving the whole 112. So that's going to move quite a bit. But what you do to set it up to a reference is you can either point at the moon. So if you can see the moon, you can point the azimuth and the elevation through the manual controls at the moon, and then say track from there on the moon, and it'll just keep tracking. Or what you can do is very similar to what Rex does. If you've got a reference point, you line it up with the reference point, and then you put via the USB port on this controller, you put the azimuth and elevation of the thing that you're referencing into this, and go set it at that, and then go to the moon.
So you will have a rifle scope.
Yeah, well and truly.
Yep.
Well, it's still.
What's a typical reference point?
Anything you can find when you're out.
Correct.
Pardon?
One of the stars, I guess.
Oh no, because during the day you can't see the stars.
Oh, okay, so it's a land-based.
Yeah.
Usually it's a land-based.
Yeah.
It's actually quite difficult to find reference points, because you go into Google Earth and you see, oh, there's a farmhouse there a kilometre away, and then that's looking down, and when you get there,
You go, where is it?
there's trees all around farmhouses, you know, they have hedges and things, and you can't pick where the thing is.
I have a reference point at home, which is fantastic, across the other side of the valley, which is a hexagonal house, which on Google Maps looks like a hexagonal house, and it is just a little bit above where I am, up on the hill. So I know that that's the azimuth, and I know what the elevation is.
Yeah.
So,
See, the Tasman Bridge used to have a blue triangle on it, and they don't have it anymore. I don't know why.
okay.
Right in the centre,
Okay.
and which I used to use as a reference. But there is a red and a green light, and it turns out the red light is exactly 35 degrees from my house.
Okay.
But I get caught with that, because you come out in the middle of the night to work somewhere. Oh, the Bridgewater Jerry's come down the roof, and you can't see the light.
Oh, the Hobart factor.
Well, can I just say, up here with the trees, there are very few
That's reference
points that you can pick
Well,
up.
the mountain. Yeah.
Yeah, bit of a problem at night though.
Are there lights on them?
Sometimes.
But one of the problems with the mountains, it's inevitably in cloud.
Yeah. So yeah, but you basically do the same thing that Rex does. Find a reference point and then move from that reference point to the moon, because you know what that reference point is, so you know where the moon is with WSJT. The only thing that this advantage that this gives you is you can then either go to the reference point and then say go to the moon, because it from a GPS point of view it knows where it is and where the moon should be from where it is, or you can go to the moon and just go start tracking and it'll stay on the moon.
I mean, the other thing you can use in the daytime is the sun.
Yeah. Oh, and there's sun tracking on that as well. So yeah.
And if all else fails, you go outside here, and we have another tracking system.
Correct. which David's talking about.
Yes.
A Gippstech.
Yes.
So yeah. So anyway, that's our what's the time? Oh, it's 8:30. We've done an hour.
Used up your talk.
Where did that go? No, well, that's good. That's very good. Okay, well, fortunately we had a VK7 OTC on the screen all the time, which is excellent, which means I don't need to do an ID. We tonight we don't actually have any videos that we're playing tonight. I thought there was way too much on the actual program, so there's no videos tonight. We'll finish off at that. This has been the Radio and Electronics Association of Southern Tasmania with our DATV Experimenters night, and I thank Rex for coming in and giving us a talk, giving us two in fact. And look forward to the talk at Gippstech. Thank you, Rex.
Thank you.
So we'll wrap it up at that and catch you. We're on next week from 7:30, and we stream to YouTube, and we also go out on RF at 445.6. And that's a meg less than it used to be. So if you have a set-top box that is tuned, you will need to retune it. Is that somebody at the door? No?
Hello? Hello?
No? Okay. Possum? Maybe possum. But anyway, we'll wrap up at that and 73, and we'll catch you next time.